A pleasant day, STEM learners. This is Sir Peter, your statistics and probability teacher. For this video lesson, we will now talk about probability distribution after discussing the concept of random variables. So at the end of this video lesson, you should be able to illustrate and construct a probability distribution for a discrete random variable and its properties. So what is a probability distribution? So a probability distribution is tabular in form. So it is consisting of values of a random variable, which we discussed on the previous video lesson. And take note that every random variable has a what we call a corresponding probability of values. So meaning every value for the random variable will be represented by a fractional part of a probability. So here are the properties of probability distribution that you need to remember. Let's have the first property. Property number 1, the probability of each value of the random variable must be between or equal to 0 and 1. Remember the concept of likelihood for events. When we say 0, it means this is an impossible event. And when we say 1, this is a sure event. So example of a impossible event is the probability that it will snow in the Philippines. Now, if today's recording is Wednesday, then the probability that it will be Thursday tomorrow is a sure event, meaning there is 100% chance that it will be Thursday the next day. So that is a probability, which is what? So notice that probabilities will always go between 0 and 1, and it can never go beyond 1 or beyond 0. So meaning the closer you get to 1, the more likelihood that the event might happen. The more likely the event might happen. And the more it gets closer to 0, the more that the event might not like to happen. So always remember this symbol for compound inequality. We have the probability of the random variable x is greater than 0, but less than, greater than or equal to 0, but less than or equal to 1. So if in case you get an improper fraction, then that's impossible because that is not within the boundaries of 0 and 1. But if you have fraction less than 1, then those are accepted. Probabilities which are negative are also not accepted. Okay? For as long as it is between 0 and 1, then that possesses the property of a probability distribution. Now let's proceed now to the second property. The sum of the probabilities of all the values of the random variable must be equal to 1. In symbols, we say that the summation of the probability of the random variable x is equal to 1, meaning when we add all the possible outcomes and their corresponding probabilities, the sum must be equal to 1. Now, let us apply those properties of the probability distribution on the next examples. So let us determine whether the distribution represents a probability distribution or not. Let's have the first set. So we have the random variable x, 1, 5, 8, 7, 9, with their corresponding probabilities of the random variable x. We have 1/3, 1/3, 1/3, 1/3, 1/3. So notice that it possesses all the characteristics of the probability, which is 1/3 is between 0 and 1. But notice the second property. When we add all the probabilities or the summation of the probability of the random variable x, then we have 1/3 plus 1/3 plus 1/3 plus 1/3 plus 1/3. So there are 5 1/3 that we add. So therefore, the answer is 5/3. And since it is not equal to 1, therefore it does not possess the second property, although it possesses the first property of a probability distribution. Therefore, we can conclude that this is not a probability distribution. So for a distribution to be considered PD or probability distribution, it should possess both qualities. The summation is equal to 1 and the probabilities must be between 0 and 1. Let's have now the next example. Suppose that the given are the probability of random variable 1 is 0.20. The probability of random variable 2 is 0.50. The probability of random variable 3 is equal to 0.30. Let's plot them on a table of values. So we have x and their corresponding probability of the random variable x. So we have 1, 2, and 3 as random variables, and their corresponding probabilities are written 0.2, 0.5, and 0.3. So first, all of them are between 0 and 1. So that's check for property number 1. With respect to property number 2, let us get the summation of all the probabilities. We have 0.2 plus 0.5 plus 0.3, and the probability is 1. So therefore, the answer is a probability distribution. Let's have this example. So we let the probability of the random variable x be equal to x over 10. And the values of x are 1, 2, 3, and 4, respectively. Plotting them on the table of values, so we have 1, 2, 3, 4 for the random variables. And for their corresponding probabilities of the random variable x, we have 1 over 10, 2 over 10, 3 over 10, and 4 over 10, respectively. Applying all the properties are all the values of the probabilities between 0 and 1. Yes, so it satisfied the given condition. Now let us use property number 2 in getting the summation of the probability of the random variable x, and it should be equal to 1. So we have the summation of the probability of the random variable x is equal to 1 over 10 plus 2 over 10 plus 3 over 10 plus 4 over 10. So 1 plus 2 plus 3 plus 4 is 10. And we copy the common denominator, that is also 10. And we know that 10 divided by 10 is equal to 1. So therefore, it possesses both properties. The given example is called a probability distribution. Now, the next skill that you need to learn is how to construct a probability distribution given certain situations. So the first one is to write all the possible values without repetition of the random variable on a table. So always arrange the values in ascending or descending manner. So what's important is you were able to organize your possibilities. Number 2, we write the corresponding frequencies of each. So we count how many times did a particular data or random variable appear or a probability appear. Number 3, write the probability of each value by dividing its corresponding frequency by the total frequency. So later, we're going to do this steps in constructing a probability distribution. Let's have illustrative examples. So we have to construct a probability distribution of a random variable. Let's have this example. So suppose there are 3 coins which are tossed. So observe that we represent the random variable as capital letter C. And what is C? Z, that is the tails. Okay? So using the fundamental rule of counting, how many total possible outcomes could we have if we toss 3 coins? So that is 2 times 2 times 2. So we expect 8 possible outcomes, right? Observe this one. Let's list all the possible outcomes in tossing 3 coins for coin number 1, coin number 2, and coin number 3 respectively. You can also use a mapping diagram, a tree diagram to determine the possible outcomes. But here is how we are going to list the Z values. Remember that the Z is represented by the number of tails. And let us associate them with the outcomes. First, we have, for the first coin, we have age, second coin, age, and third coin is age. So how many number of tails did we get from a result which is head, head, and head? Very good. The answer is 0 tails. So this 0 is representing the random variable, meaning there are no tails in the given outcome. Next, we have head, head, tail. Now, how many tails did appeared on this possible outcome? Very good. There is 1. Another possibility for the random variable 1 is an age, T, age. Again, the number of tails is 1. For the next outcome, we have age, head, tail, tail. So how many tails did we get? 2. Then we have T, tail, head, head. How many random variables did we get? 1. So 1 tail only. Next, tail, head, tail. So how many tails did we get? Very good. 2 tails. Tail, tail, head. So we also have 2 tails. And the last possible outcome in tossing 3 coins is tail, tail, tail. So how many number of tails we get? We have 3. So in this particular example, we can already conclude that the random variable Z, which is represented by the number of tails, no, has how many random variables? 4 possible random variables, and they are 0, 1, 2, and 3 respectively. After determining the possible outcomes with their corresponding random variable Z, then we can now construct the probability distribution. So how do we do that? So first, you name the table as the probability distribution of the random variable Z, where Z is the number of tails that occurs when 3 coins are tossed. So again, let us list all the possible random variables. As I've said, we have 0. Now, how many times did it appear on the possible outcomes? We have 1, 2, and 3. For the frequency, we have 1, the frequency of 0. What about the frequency of 1? So we have 1, 2, 3. So we have 3. Okay. Then for the random variable 2, we have 1, 2, 3. So you simply count. Okay. And then for 3 details, so it only appeared once. Okay, once. So the correct answer is 1. Then, since the total number of outcome is, how many total number of outcomes that we have? 2 times 2 times 2. So we have 1, 2, 3, 4, 5, 6, 7, 8. Therefore, when we write the probability of the random variable z for this column, then we will get 1 over 8, 3 over 8, 3 over 8, and 1 over 8 respectively. Notice that all of the probabilities are between 0 and 1. And when we get the summation, what do we get? 1 over 8 plus 3 over 8 plus 3 over 8 plus 1 over 8. The summation of the probability of the random variable z is equal to 1. So again, it possesses the characteristic of a random variable. Now, let's illustrate another illustrative example. So Rico was curious about the number of customers coming daily in his parlor shop. So he decided to record the number of customers X, this is our random variable, coming to his shop daily for 2 weeks. So we will construct a probability distribution of random variable X, which records the number of customers. So based from the record of Rico, there are 14 days or exactly 2 weeks record of data that he gathered. Following that principle, so listing down all the number of customers. So the least number of customers is 5. So this is our first random variable. The frequency is 1. So it happened during a Sunday, second week of Sunday, in which 5 customers went to the parlor shop. And for the random variable 6, let us count 1, 2, 3. Did I miss 1? So let's see if that is 3. Correct. What about the random variable x7? So if Rico had 7 customers during Monday, second week, and Friday, first week. So we have the frequency 2. Then for the random variable 8, 1, 2, so only 2. Random variable 9, can you count? Very good. There are 3. And lastly, for random variable 10, how many? Correct. So that is 3. And what is the total? The total number of frequency is 14. So therefore, 14 now will be our denominator in writing for the probability of the random variable x on the third column. So for the first one, we have 1 over 14. Or you can also express it in decimals, 0.0714 or 7.14%. 3 over 14, 2 over 14, 2 over 14, 3 over 14, and 3 over 14 respectively. Notice that all of the given examples possess the first property in which all the probabilities of the random variable x are between 0 and 1. And again, When you get the summation of the probability of the random variable x, the answer is 1 because 1 plus 3 plus 2 plus 2 plus 3 plus 4 is 14. Then copying the common denominator, we have 14 also. And 14 divided by 14 is 1. So again, it possesses the second characteristic. So I hope you learned something about week number 1 on what is the concept of a random variable and how do we apply the concept of probability distribution in real life situation. So remember that in life, we are always associated with probabilities, just like the random variable. People are considered random and people are different from each other. That's why every person is a variable. And every time that we choose something, there are possible outcomes to it, resulting to corresponding probabilities as well. Either it is a success or a failure in life. So the concept of random variables helps us to become wise decision makers in the future so that we will turn into different results of our success and failures in life. So I hope that you learned something from our week number 1. For the next video lesson, we will talk about week number 2, how to compute for the mean of the discrete probability distribution, the variance of the discrete probability distribution, and lastly, the standard deviation of the discrete probability distribution. Again, this is Sir Peter, your statistics and probability teacher. Happy learning!